Alright, so in this video, we're going to be continuing on our example of linearization. But before we do, I don't know if I said anything about changing the notes. So we're going to be looking at notes on Canvas. So look under Files. Okay, and in that section, we're going to be taking a look at 5.1 through 5.3 of some new notes. Okay, the author does a really good job with these systems, and so I thought we'd switch for the last few days. Good. So also, before going on to the example, I just wanted to briefly show you what we're doing again. So we started with saying that if I have x prime equals f of xy and y prime equals g of xy, then to linearize the system, we're actually linearizing f and g, and so then x prime and y prime will become f of ab plus f sub x at ab times x minus a plus f sub y at ab times y minus b, and y prime will be g of ab plus g sub x at ab times x minus a plus f sub y at ab times y minus b. Good. Now, if AB is an equilibrium solution, then what does that say about these two values? These are 0. Good. And so therefore, what we have is that, so this isn't really x prime anymore, right? This is, I should have put approximately equal to. So our new system, I'm actually going to make this have some new variables. I'm going to let u be equal to x minus a, and v be equal to y minus b. And so what we're doing here is we're moving from the xy coordinate system to the AB coordinate system. So this is u and v. Okay, and so if I write down the differential equations for u and v, what I get is u prime is just going to be x prime, v prime is y prime, but then u prime is going to be equal to, maybe I should write this in vector form. I'm looking at this system here that I'm rewriting in vector form down here, or matrix form. So I'm going to have f sub x at AB, f sub y at AB, g sub x at AB, g sub y at AB. And now instead of x minus a and y minus b, I'm just going to have uv. And so this is the linear system that we're going to study for this, around this equilibrium at AB. Okay, and then we're just going to repeat this process over each equilibrium solution. And so the main matrix that all of this stuff really can be forgotten, except that this is the matrix that you want to analyze at each equilibrium solution. And how do we do that? Poincaré classification. Good. So let's go ahead and set up the next example here. So x prime equals x squared minus 3xy minus 4, and y prime equals xy plus y squared. Good. Now again, the very first thing we always do, equilibrium solutions. And so, well, that means that the derivatives are equal to 0. Right, so 0 equals x squared minus 3xy minus 4, and 0 equals xy plus y squared. Good. Now we have to solve this system simultaneously, and I'm thinking it's going to be easier to solve the second one first because there's a y that I can factor out. The top one doesn't have anything to factor. So I'm going to solve the bottom one first. I'm going to say y times x plus y equals 0, because that will mean that either y equals 0 or y equals minus x. Okay, now if y is equal to 0, I'm going to go back to my other equation, and so if I plug in y equals 0 to that, I just get that x squared minus 4 equals 0, right? And so that means that x is equal to plus or minus 2. Okay, and so good. So now remember that these come in pairs, right? And so the solutions so far are going to be 2, 0, and minus 2, 0. Okay, now I go to y equals minus x. And if I plug that in, I get x squared plus 3x squared minus 4. So that's going to be 4x squared plus 4, or minus 4 equals 0. Good, so that looks like x squared minus 1 equals 0, x equals plus or minus 1. Good. Now remember again that these are pairs, so if x is plus 1, y is minus 1. And if x down here is minus 1, then y is positive 1. Oops. And so therefore, we see that there are how many equilibrium solutions? 4. Good. So we're going to be analyzing this differential equation, the system of differential equations, around all 4 equilibrium solutions. All right. So now we want to linearize the system. And so how do we do that? Well, remember that our L1 of xy in this case is going to be x squared minus 3xy minus 4, right? Oops, I didn't want to write that. That's our f. And our g is going to be xy plus y squared. Good. And we want to convert that to x prime. Whoops. I guess we'll go ahead and be a little bit sloppy there. It'll be basically x prime is f sub x, f sub y, g sub x, g sub y. I'm just setting this up for the next video because we're just about out of time with this one. And so I'm going to start here at the linearization of this system in the next video, and we're going to analyze our system of differential equations at each of the 4 equilibria. Good. Okay, I didn't want to get too far into this video today. And so yeah, so remember to look in the Canvas for the notes to this, and there's a really nice write-up. I think the author does a good job at describing what we're doing. Okay, I'll talk to you later.